factor 8, and those form. They come in and they're the active form of the coagulation factors, and by the mechanism of activated protein C, they're pushed back into their inactive form. So those are pretty much the mechanism for, in normal healthy endothelial cell, anticoagulant producing agents. So the next thing to go on to would be if you have an injured endothelial cell, I guess. So when you have injured endothelial cells, the first thing that happens is the endothelial cells, they stop producing all of these factors that are anticoagulant agents and are vasodilators. And instead, what they start producing is a couple of different molecules. The first one, so this is my injured endothelial. And one thing that they produce is endothelin. And it goes into circulation, and it also passes through the basement membrane and acts on smooth muscle. And when it acts on smooth muscle, it actually causes vasoconstriction. And this is one of the ways where you get vessel spasm, which is basically where at the site of an injury you have like a significant amount of vasoconstriction. And not only does this prevent excess blood loss, but it also helps stimulate platelets and other coagulant factors to be recruited to the area so that repair can be as quick as possible. So the other thing that the injured endothelial cells start producing that if they were healthy they would not normally produce is what's called VW factor. And you guys know what VW factor is? There's a disease named after it.
Von Willebrand's?
That's correct, von Willebrand factor. And so these von Willebrand factors are produced by the injured endothelial cells, and they're basically secreted, and they just remain locally and attach themselves immediately to that extracellular matrix. They attach specifically to collagen fibers of the extracellular matrix, which is one of the reasons that, won't get into it now, but there are a lot of diseases related to poor collagen synthesis or collagen degradation, and as a result of these diseases, these von Willebrand factors can't stick, and you end up with, basically an inability to clot and an inability of the platelets to attach. And one of the natural reasons or natural ways that the collagen is poorly produced is just with age. We get worse at producing collagen, or correctly synthesizing collagen. So what happens is once these injured endothelial cells produce these von Willebrand factors, this enables the platelets that are in their inactive form and kind of just passing through your vasculature to come in contact and connect. So this is your inactive platelets. So they come and they start binding to the von Willebrand factors. And just have a lot of platelets. And they basically block off this area so that to begin the process of clotting. And the first thing that this is called specifically is platelet adhesion. So the platelets come in, and the receptor that they use to bind to von Willebrand factor is called glycoprotein 1b receptor. So these are your glycoprotein 1b receptors. And when these glycoprotein 1b receptors bind to the von Willebrand factor, that's when your platelets truly become activated. And so once the platelets adhere to the extracellular matrix, what ends up happening is these platelets, which I'll draw a bigger one now, these platelets begin to dump off. They have all these granules inside of them, and so they dump off what they have stored in their granules, which includes things like histamine, ADP, which is really important, calcium, serotonin, which serotonin acts as a vasoconstrictor, and they through a couple of processes they start secreting other things that aren't necessarily held within their granules, but are synthesized through a multi-step process. So like these granules, which have stored a lot of things, and they actually are able to, the granules are actually able to pick up some of your coagulation factors from the blood when they're just circulating around, and so they've stored a lot of these coagulation factors to like basically keep them localized, which is key to just, because this whole process takes a matter of 30-60 seconds to get to this point, and the whole thing really runs in the matter of a minute, 2 minutes, and clots are actually even broken down within like 40 minutes of being formed, because that's how fast this whole process goes. So the granules release calcium, which just basically acts to hold a lot of things together. A lot of your coagulation factors are negatively charged, and so they would want to be repelled from each other, but calcium sort of acts to like hug them in together, keeping them close, because as I'll show you with the cascade, they're required to stay close to each other. ADP is released, and ADP acts both on itself and acts in the recruitment of other platelets. It recruits and activates other platelets, and when it it's also it does this recruitment along with another enzyme, which is what is it? Thromboxane A2. And thromboxane A2 is not secreted by the granules, but actually is synthesized through a cascade along the cell membrane. And when thromboxane A2 is released, it also acts in platelet recruitment, and it also, along, just like serotonin, it acts on smooth muscle. And these are what cause the vessel spasm, the vessel constriction, along with endothelial, which is just important for minimizing the blood loss. So basically, what these so ADP and TXA2, they basically just take, when the inactive platelets come in contact with them, they become your active platelets, and then they kind of go through this whole process again of dumping off their granules, more ADP, more TXA is produced, and it just continually is, it's recruiting more and more platelets to the site for binding. So, any questions so far? I feel like it's kind of dry, but you know, gotta build your foundation.
So the van,
Yeah, von Willenbrand factors.
yeah, so those factors, when they basically get full, I mean, are there a certain amount of those that kind of connect to the extracellular?